What's brighter than an entire galaxy, more mysterious than a black hole, and right in Hubble's crosshairs? Meet Quasar 3C273. As one of the nearest quasars to Earth, this celestial giant provided access to secrets of the early universe. What is equally surprising is that it can make the trip from Earth to the Moon in under 14 minutes as it hurtles through space. But don't worry, this giant is very, very far away. Hubble just managed to cut through its blinding brightness and uncovered some seriously weird stuff. Blobs, filaments, and even what looks like a galactic feeding frenzy happening around a monstrous black hole at its corner. This is the kind of cosmic drama that makes you realize just how wild the universe really is. We are trying to understand what is so special about this, how Hubble did it, and why these results are changing our views of quasars, black holes, and galaxies. If you thought space had run out of ways to be surprising, you were mistaken. Stay with us to find out what Hubble found. If you want to turn a black hole into a quasar, not that we can actually do that, we need an endless supply of gas, dust, and even stars to gobble up. Now, if we can achieve that, you will see that the gas forms an accretion disk that looks like someone just drove over the clouds. The black hole's intense gravitational field, along with the pressure from surrounding material, heats the disk up to extreme temperatures, which causes the accretion disk to light up. This is what makes quasars so dazzlingly bright across vast distances. Quasars are perhaps the most difficult to understand among all cosmic objects. The energy inside quasars can be seen billions of light years away, and they serve as a balance to the black masses at the heart of galaxies. Black holes will capture whatever surrounds them and throw out the light that blinds all our telescopes. One of the most interesting aspects of quasars is the combination of supermassive black holes and active galactic. A galactic nucleus that is active can be measured billions of light years away and can be found anywhere in the galaxy. Quasars, along with their high brightness, facilitate the observation of the evolution of galaxies and their cores' supermassive black holes. An even more interesting thing is not every galaxy has a quasar at its center. A supermassive black hole will only turn into a quasar when it is situated at the accretion disk of gas and dust. If a black hole does not eat, it becomes inert and falls into a deep recess of dormancy. Quasars are not only fascinating objects of scientific research, but also clues for understanding the universe's history with its most extreme forces. And when it comes to studying them, few are as famous or as weird as this celestial giant. Background on 3C273. This is no ordinary quasar. This distant beacon was first introduced in the 1960s and stands out as the very first one, which is a key point in our universe comprehension. The quasar's brightness and radio waves were initially puzzling to scientists, yet further studies revealed that the source of the energy was a supermassive black hole, located at the very center of a faraway galaxy. This finding not only solved a previously unsolved mystery, but also initiated a new era in the study of objects regarded as supermassive. Situated in the Virgo constellation at a distance of about 2.4 billion light-years from Earth, this distant beacon is one of the nearest known quasars. The extreme brightness of the quasar is such that if it were in our sky, it would appear to be as bright as the sun, even though it would be tens of thousands of light-years away. Because of this, the quasar is the perfect object of study for getting to know the physics behind the emission processes in quasars and the monster black holes that power them. Role of the Hubble Space Telescope. We've been talking about the incredible brightness of the quasar for quite some while, and that's important because the Hubble Space Telescope was able to cut through the brightness and study this energetic quasar. It helped scientists to see very closely all that was happening around the supermassive black hole. Hubble's observations revealed a lot of unique features, from a giant jet of material blasting far beyond the quasar's galaxy, to blobs of matter that are possibly small galaxies in the process of being devoured, and even a mysterious L-shaped filament up near the black hole. These results give us a rare look into how the quasar, its host galaxy, and the space immediately around them interact. Hubble has allowed this cosmetic lighthouse to be transformed from a blinding enigma into a detailed case study of how quasars work and evolve. Discoveries. Number 1. The enormous jet. The jet is longer than the distance of the galaxy, measuring 300,000 light-years. The poles of the black hole emit a jet that is extremely hot and travels almost at the speed of light. Researchers were quite thrilled to find these recently taken images of the jet, since they had archived images of it 22 years ago. What Hubble observed turned out to be something very interesting. These jets seem to increase in speed as they go further from the black hole, which is likely due to indeterminate relations with magnetic fields. Understanding this behavior helps in comprehending the fact of how such jets are capable of transferring energy across intergalactic distances and affect the surrounding regions. Number 2. Unusual structures around the black hole. Within 16,000 light-years of the black hole, Hubble detected an array of weird things, as described by researchers. These include blobs of varying sizes and a peculiar L-shaped filamentary structure. Scientists speculate that some of these blobs could be small galaxies being drawn toward Quasar's supermassive black hole, providing it with the gas and dust needed to fuel the quasar. Number 3. Black hole feeding behavior. Hubble's detailed look also revealed something about the feeding behavior of black holes. Its high-resolution 3D simulations show that rotating black holes twist up their surrounding space-time, eventually ripping apart the furious vortex of gas that encircles and feeds them. This causes the disk to tear into multiple subdisks. Black holes first consume the inner ring. Then, it goes on to feed on the debris from the outer subdisk and spills inward to fill the space left by the completely devoured inner ring. The feeding process keeps repeating. One cycle of the continually reoccurring eat, refill, eat process takes only a few months, which is a remarkably short period when compared to the hundreds of years previously proposed by researchers. Previous researchers believed that accretion disks are fairly tidy. In some models, gas and particles spin around the black hole in the same plane and direction as its spin. Then, over the course of hundreds of thousands of years, gas particles spiral toward the black hole, feeding it. However, the Hubble telescope shows that the areas surrounding the black hole are far noisier and more chaotic than previously assumed. Future prospects. The discoveries made by Hubble are just the beginning. The next big leap in understanding this luminous object, and quasars in general, comes from the James Webb Space Telescope. With its powerful infrared vision, it can peer through the dust and debris that often hide cooler, fainter structures in quasars. It's like having a pair of cosmic X-ray glasses that can see through all the blinding light that makes this cosmic lighthouses so difficult to study in detail. JWST's infrared abilities will be especially useful for examining the quirky features around this stellar powerhouse, like the L-shaped filament and those strange blobs of material. With these new tools, scientists could finally get a clearer picture of how the black hole's accretion disk behaves and what exactly is happening with the gas and matter swirling around it. But the excitement doesn't stop there. James Webb Space Telescope could help answer some of the bigger questions about quasars: how they evolve over time, whether they follow a similar pattern, or if each one is a totally different beast. By combining the data from Hubble and James Webb Space Telescope, astronomers will have an even sharper view of the universe's most powerful and mysterious objects, pushing the limits of what we know about black holes, galaxies, and the forces shaping the cosmos. The future of quasar research is looking pretty thrilling. Scientific context. A series of discoveries concerning this distant beacon play a decisive role in recognizing quasars, supermassive black holes, and a galactic evolution. Quasars are more than just remote light sources. Their active centers show us how matter behaves under extreme conditions. They are windows to galaxies, displaying how supermassive black holes affect the environments via their surroundings and how galaxies emerge over the years of their existence. Scientists can gain more insight into the sophisticated processes that occur when a black hole is actively feeding by focusing on quasars, such as 3C273. The material that ineffably goes into a black hole's accretion disk is heated up to such high temperatures that it emits great radiation that sustains the quasar's glow. These high-energy emissions can lead to the whole galaxy being transformed, influencing star formation and even causing the galaxy to combine with another one. Moreover, studying the jet emissions from supermassive black holes is useful for astronomers to explore the way these colossal space gods throw matter at almost light speed, which in turn is affecting the background space and is to be considered as a possible regulating factor of the galaxy's growth. The new discoveries about this energetic quasar step up in creating the perfect picture of how these extreme objects function, assisting in the closing of the gaps in our knowledge of the early universe and what are the key roles of quasars in shaping galaxies over time. Engagement. The universe is constantly throwing us curveballs, and if this cosmetic lighthouse has sparked your curiosity, you're in for a wild ride. Follow the ongoing research from Hubble, James Webb Space Telescope, and other space missions to catch the next surprising revelations that are out there.